To be sure that we are meeting the law of conservation of matter and mass, we need to balance our chemical equations. These are those coefficients that we put before the chemical compounds, because the chemical compounds are written based off rules and ratios that have been set based off ionic and molecular compounds. Whereas, depending on what the reaction or how the reaction takes place, we need to make sure we have an equal number, and that's why we have to balance with our coefficients. First, we want to look at each individual compound and make sure that those formulas have been written correctly based off the rules of the type of compound they are. Therefore, identifying molecular versus ionic compounds is absolutely essential, and then knowing their formulas. Because if you don't know that, it will be a struggle to make sure you balance correctly. When we finish and go through and balancing, those coefficients need to be in the lowest reduced terms. So if you have a base of 2 that can divide all coefficients, you want to make sure that you do that, just like we do with our ionic compounds. A nice visual looking over on the side here of how this works. We have CH4, which is also known as methane, and we have oxygen. So oxygen reacts in the presence of air. That is its chemical property that allows for this transformation to occur. On the product side, we make CO2 and water. Now, if we do not balance this equation, if we just say we have 1 methane, 1 water, we get 1 oxygen, 1 CO2, and then 1 water, we don't have the appropriate amount. We need to make sure we have all 4 hydrogens accounted for, and those are going to be taken into 2 separate waters. Then we want to make sure that we have the 1 carbon accounted for, and then we have to make sure that the number of oxygens are as well. And so that is why we use the coefficients. So we need 2 oxygens in this reaction for every methane to produce 1 CO2 and 2 waters as a product. This allows us to maintain the law of conservation of matter. There are several different ways to balance a chemical equation, and you'll see these definitely when you're in lecture and practicing. The rules that are here come from ALEKS, which is the homework we use, and they work, but it takes time and practice. I would pause the video and then write these steps down, and I'm going to use these steps in our examples in the next slides. But taking a look at them. You want to look at the chemical equation and you want to identify the most complex compound. This is going to be a compound that has multiple subscripts, the most atoms in it, so on and so forth. And that's going to be your starting point. We're going to assign the number 1 to that most complex compound because typically it's going to have the lowest coefficient possible. Once we have identified that compound, then we're going to pick an element within that compound to balance first. Typically, I picked the first element written in that compound. You're going to balance an element that appears only once in a compound that has an unknown coefficient. Don't worry, I'll show you how this works. Repeat steps 2 and 3 until you've balanced every element. If for some reason you had to have fractions to satisfy a balanced compound, you need to clear those fractions. If you had written the coefficient 1, those actually are not written in chemical equations because just the presence of that compound tells us there's 1 there. So we tend to omit those. Tips: save your diatomic elements. These are elements with a subscript but not in a compound. These are going to be what we call our Brinkelhoffs, and we'll talk about this later again, but bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. These 7 elements are so reactive that they will form bonds with themselves, hence diatomic, in order to be stable, but they will preferentially bond with other elements as well. If a polyatomic ion appears on both sides of the arrow, treat the polyatomic ion as 1 ion to balance, not separate elements. These are 2 tips that definitely help when you're going to go through and balance chemical reactions. So let's practice some. Now we're going to be practicing our balancing. There is simple balancing and there's more complex balancing. Alex uses the terms non-interfering coefficients versus interfering coefficients. So non-interfering coefficients means we can go through and balance a chemical reaction without having to go and do some additional math with fractions and whatnot. Interfering coefficients are a little bit more complex, and we'll do that next. All right, so have your rules that we wrote down from the previous slide ready to go as we go through and follow them. Before I start with the rules and balancing, I like to write everything I'm working with down. Looking at our first chemical reaction, I like to write the elements and my reaction underneath the arrow. The reason I like to do it this way is that helps me separate how many of each of the elements I have in the reaction or in the reactants versus the products. I have 1 sodium in the reactants, 2 in the products, 1 in the sulfur, 1 in the products, 1 sulfur in the reactants, and 1 sulfur in the products. All right, now starting with my rules. Assign a 1 to the most complex compound here. It's going to be the one that has the most subscripts, because the subscripts is really what's going to dictate how we go through and balance. Therefore, I'm going to put a 1 next to the Na2S, because that 2 is going to dictate how balancing occurs. With this, I take a look and step 2, pick an element to balance. I like to start with the first one, sodium. So then I want to make sure it's balanced across the arrow. Currently, this one coefficient maintains that we have 2 sodiums on our product side. So I need to make sure I have 2 sodiums on my reactant side. So I'm going to put a coefficient 2 in front of that sodium. I'm going to change that down in my list, and when I see those numbers match, I'm going to put a check mark so I know we have cleared that element. Then I'm going to move on to the next element in that complex compound. The 1 distributes to any element within that compound, and so we still have 1 sulfur. Luckily, on the reactant side, we have 1 sulfur as well, therefore it is balanced as is. The last step in our rules says to clear any fractions, which we do not have, and omit the coefficient 1 because it's not necessary, just like we don't write the subscript 1 either. The next example, I suggest pausing, seeing if you can solve this balanced equation, and then starting up and matching it with mine. First, I like to write down the elements I'm going to have to balance in this chemical reaction. I have 1 potassium on each side. I have 2 chlorine on my reactants and 1 chlorine on my product side. Now I can start with my rules. So identify the most complex complex compound in this reaction. It's going to be the compound that has the most atoms or a subscript that will dictate throughout. So I'm going to pick my chlorine as what I'm going to start with because it has a coefficient. It's something other than 1. Therefore, it's going to dictate what happens to the other elements. So with this 1 distributes. I still have just those 2 chlorine. I'm going to move across to my product side, and I've got a chlorine within that compound, and there's only 1 there. I'm going to put a 2 because that 2 is going to distribute to the chlorine as well. Change my number down below so I can show that I've balanced the chlorine. All right, now we have to go through and check for our potassium. It was 1 to 1, but by putting the coefficient 2 with that KCl, we now have 2 potassium on that product side. Therefore, we need to go back to the reactant side and make sure is it still balanced. On the reaction side, it's currently 1. It needs to be 2. So I put a 2 coefficient, and my potassium is now balanced, and I'm going to omit the 1 that was written for that chlorine. Now we're going to be balancing reactions that are slightly more difficult. These reactions are going to have coefficients that interfere, which means in order to balance it, you're going to have to go back and change that most complex compound that we started with. So I'm going to show you two different ways in which to do this. Starting with our first reaction. Again, I like to write down the elements that are participating in this reaction and how many are already provided based off their subscripts. Step 1, identify the most complex compound within this reaction. This is going to be the product, so Fe2O3. I'm going to put a 1 in front of that and have that balance. All right, so now we're going to go through and we're going to start changing or balancing the rest of our coefficients. So starting with iron, right? So we've got 2 iron, and we've only got 1 on the reactant side, so I'm going to put a 2 there. All right, so my iron gets balanced. Then I have my oxygen. I've got 2 on my reactant side, 3 on my product side. Well, those don't go into each other. So let's find a common number that they can go into. 2 and 3 can both go into 6. 2 can go into 6 3 times. 3 can go into 6 2 times. So we want to figure out a way, or these become the coefficients to balance that out. So if I put a 3 coefficient with that oxygen, I can get up to 6 oxygens. Now the problem here is we had put a 1 with our product. This is that interfering coefficients. I'm going to have to erase that 1, and I'm going to have to put a 2 there. So that 2 times 3 gives us 6. But because we've interfered with the original coefficient, any other atom within that compound that that coefficient is associated with may change as well. So originally we only had 2 iron, but by putting the coefficient of 2 there, that now makes it 4 iron. So it is no longer balanced, and I have to go back and fix it. So I'm going to put a 4 down below. I'm going to have to erase that coefficient 2 because it no longer worked. And I'm going to put a 4 with that coefficient of 2. So I have 4 iron, 6 oxygen, and we are balanced. So that is one way in which you can balance chemical equations, just going and changing the coefficients as necessary. I'm going to show you the fraction method with this next one. All right, so starting with what I have, so I have silicon, hydrogen, oxygen. Okay, I've got 4 and 1, 10 and 2, 2 and 3. There's a lot going on there. Alrighty, so we want to identify the most complex compound present. It's going to be the first one that's written in this reaction. So I'm going to put a 1 there. All right, so what I want to do first is I want to balance an element from that compound. You want to balance an element that it only appears once on the product side or the reactant side, and is most simple in which to balance. Again, I always like to start with the first one, silicone. All right, so here I have 4 silicone, so I'm going to start with this guy. I have 4 silicone on my reactant side, so I'm going to need 4 on my product side. My silicone is balanced. Next, balance an element that appears only once in a compound that has not already been balanced. So what I have left is I have oxygen, and that oxygen is in 2 different compounds on the product side. Whereas the hydrogen in this water is the only hydrogen that is not accounted for thus far with a coefficient. So that's what it means by find an element that has an unknown coefficient. We haven't solved for it yet. So now I'm going to solve for my hydrogen. I have 10 hydrogen on my reactant side. I've got 2 on my product side. That's pretty easy. I can put a 5 there. So once I put my 5 there, that 5 now switches my hydrogen to 10. That leaves us one last element in which to balance. Oxygen. So now we have oxygen. We have got 2 oxygen on the reactant side, and we've got 3 oxygen on the product side. We want to figure out how many, well, actually that oxygen number changed. I apologize for that. Because we now have coefficients in each of those products, we need to update how many oxygen we have. So we have 4 times 2. That's going to give us 8. We have a plus sign between these compounds. 5 times 1 is 5. So that is 13. We now have 13 oxygen to 2. What I can do now is do 13 divided by 2 as the fraction. What this allows me to do then is to clear the fraction. To clear a fraction, you want to multiply everything by the denominator, which is a 2. So if I multiply everything by a 2, I'm going to get, erase that 1, that becomes a 2. When you take 2 times 13 halves, that 2 just disappears and it becomes 13. 4 becomes 8. 5 becomes 10. They're all in their lowest reduced form as possible, and everything is now balanced throughout this process. You can check yourself again as you cleared that fraction if you need to. So now I have 8 silicone, 20 hydrogen, 20 hydrogen, 26 oxygen. I have 16 plus 10 is 26. Oh, look at that, that was fun. So you have them all balanced. You don't have to necessarily go back and check it after you clear the fraction, but those are 2 different ways to balance complex chemical reactions.